Hey everyone, welcome to this explainer. So if you've ever found yourself staring at just a massive mountain of data and wondered how on earth to turn all that raw info into predictive AI without completely crashing your systems, well, you are definitely in the right place. Today, we're really digging into the details of a highly curated tech curriculum. It's a set of tools specifically designed to scale data analysis all the way from basic, raw access straight through to advanced machine learning.
Okay, let's take a quick look at what we're covering today. First, the goal of scaling data analysis, then the foundation of fast random access, exploring with Data Lab and BigQuery, custom machine learning with TensorFlow, and finally, ready-to-use models. Let's just dive right in.
Part 1. The goal: scaling data analysis.
Now, everything we're going to look at today is built around this specific core idea. The participants would be exposed to a very deliberate sequence of technologies. This isn't just, throwing a bunch of software at the wall to see what sticks. It's a carefully engineered pathway. Each tool is literally the key to unlocking the ability to handle a much more massive scale of information. Moving right along to Part 2. Foundation: fast random access.
Think about it. You absolutely cannot build a skyscraper on a swamp, right? And you definitely can't run advanced AI on data that takes hours just to load. Fast random access is the absolute bedrock here. What this means is your system can jump instantly to a specific data point, no slow sequential scanning. It's like, imagine instantly flipping to page 500 in a giant textbook instead of having to read pages 1 through 499 just to get there. Without that blazing speed at the base layer, every single analytical step after this just grinds to a complete halt.
Part 3. Exploration, Data Lab, and BigQuery.
Okay, so once you have that foundational speed, you enter Data Lab. This is basically the analyst's workshop. When participants are exposed to this environment, they aren't just staring at boring static spreadsheets. No way. They're jumping into a fully interactive computational workspace, kind of like a Jupyter Notebook setup. It's where you write the code, visualize the data, and really start digging up those insights that are hiding just beneath the surface of all that high-speed storage we just talked about.
But what happens when your exploration leads to a question that spans millions or even billions of rows? Well, that's where BigQuery tags in. BigQuery is this heavy-lifting, enterprise-grade serverless data warehouse. It literally provides the muscle. You feed it these incredibly complex SQL queries, and it distributes the workload right across massive computing clusters. It shoots back answers at a speed and scale that would completely fry a traditional database. It's a total game changer.
And honestly, the sheer genius of this setup is how naturally it flows. Step 1, you lock in that high-speed random access. Step 2, you're prototyping and exploring right there in Data Lab. And Step 3, you bring in BigQuery to smash through those massive scaled-up questions. Every single step feeds perfectly into the next.
Which brings us to Part 4, Custom Machine Learning, TensorFlow.
Now we're getting into the really advanced stuff. Once you've got the querying down, the curriculum pushes you up into custom predictive models, specifically machine learning with TensorFlow. Now this is for those really unique, complex challenges where you literally need to build a neural network from the ground up. Yes, it absolutely requires some deep technical skills, but the payoff? You get the incredible power to train algorithms completely tailored to your own unique proprietary data.
And finally, Part 5. Ready to use fully built models.
Because, let's be real, you don't always need to reinvent the wheel. Not every single problem requires a custom-coded neural network. So the program smartly balances things out by including fully built, off-the-shelf models. Look, if you just need standard image recognition or maybe some language translation, you can completely bypass TensorFlow. You just plug these pre-trained models straight into your pipeline and boom, immediate scalable efficiency. Why make it harder than it needs to be?
There is such a fascinating duality here that you really need to master. You kind of have to become bilingual in your tech stack. On one hand, you need that granular, custom building power of TensorFlow for those truly unique business problems. But on the other hand, you need the swift, plug-and-play agility of ready-to-use models for common, everyday tasks. Knowing exactly when to build from scratch versus when to just borrow an existing model, that is the true hallmark of a great data architect. So let's bring it all together. Mastering this exact exposure journey is the absolute key to scaling. You kick things off with the raw speed of fast random access. Then you explore everything in Data Lab. You run your massive queries with BigQuery. You push the technical boundaries using TensorFlow. And finally, you speed up deployment with those fully built models. It is one complete, beautifully holistic ecosystem.
All right, I want to leave you with a question to chew on. If you had this exact tech stack handed to you today, I mean the lightning-fast speed, the massive querying muscle, the custom machine learning tools, and the off-the-shelf AI, what massive data set would you tackle first? Think about it. Anyway, thanks so much for diving into the details with us on this explainer today. Keep exploring, and we'll catch you next time.